Maybe we should look at them. Hey guys, example number 2 here. All right, let's see. I'm going to use yellow on this one. It says find the greatest common factors of the number. Easy. Easy. Let's do 24 first. That's going to be 3 and 8. 3's prime. That's 2 and 4. 2's prime. That's 2 and 2. All right, so we've got 2 times 2 times 2 times 3. Okay, so that's 24. Let's find 45. 45 is 9 and 5. Now, guys, I'm not even thinking about it, what it is. I mean, it's probably, I don't know, a 3? Just 3 goes into both of them? I don't know. Let's see. And then break 9 up into 3 and 3. So the factorization for 45 is 3 times 3 times 5. Well, let's see. Do they all have a 2? Do they both have a 2? No, so I have to skip that. Do they both have a 3? Okay, so I'm going to take this 3 and that one and put it down here. That cancels. Do they all have another 3? No. Do they both have a 5? No. So the only thing they have in common is 1, 3. That's the GCF. That's the biggest number that goes into both of them. That's it, Armand. Can you believe that? Yeah. Amazing. All right. Let's look at 35 and 54. All right. Tut, break down 35 for me.
7 times 5.
7 and 5. They're both prime, right? So that's it. So I'm just going to write 5 times 7. All right. Let's see. Ethan, break down 54 for me. 6 and 9. All right. Alex, break down 9 for me. 3 and 3. Will you break down 6 for me too? 2 and 3. Okay, so the prime factorization for 54 is 2 times 3 times 3 times 3. Do they have a factor in common? No. So what do we call these two numbers? What do we call them? No. They're not prime. They're not prime, clearly. What do we get there? Tut? They are relatively prime. Meaning that if we wrote them as a fraction, 35 over 54, we couldn't reduce it. They don't have any common factors that we could cancel out. That's a good way to think about it. Okay? So these two numbers are relatively prime. All right? Good job. Before I stop, we got any questions on this? Someone had their hand up? No? We're good? Ethan, yes, sir.
I don't really get what relatively prime is.
See, it means these two numbers are not prime numbers, are they? Right? Because I can break them down. Right? So they're not prime numbers, but in comparison to each other, they are relatively prime. Because they don't have a factor in common. We cannot reduce them if they were written as a fraction. So if we wrote two numbers as a fraction, we couldn't reduce them, we would say that these numbers are relatively prime. Okay? Because they don't have a factor we can cancel out. Yep, that's it. It said, find the GCF, then tell whether the numbers are relatively prime. These, they don't have a number, so they're relatively prime. Okay? Good job.